In this question, you have a piece of wire length 32 and you want to bend it to form a pentagon, which is shown in the diagram here. And you are given an ACDE. ACDE is a rectangle. So ACDE this one is a rectangle, and then triangle ABC is a right angle triangle. That 90 degree is here, 90 degree is here, and AB is 3x, BC is 4x, and you are supposed to express AC and CD in terms of x. AC is this length, and then CD is this length. Since it's a rectangle, these two lengths will be the same, and these two lengths will be the same. After that, you're supposed to find area enclosed by the wire. You have to show area enclosed by the wire is given by A equal to 80x minus 24x squared. After that, you're supposed to find stationary value of A. So it's same as finding solving dA dx equal to 0. And then in part 4, you have to show the stationary value of A. In part 3 is maximum. So let's look at the solution. You can use Pythagoras theorem to find AC. Okay. Remember, you have a right angle triangle. So which means Pythagoras theorem says the hypotenuse. So AC squared is just 3x holding square plus 4x holding square. Okay, and then you can work out the answer using Pythagoras theorem. So that's why it's square root of 3x squared plus 4x squared, which will give you 9x squared plus 16x squared in square root. So it's square root of 25x squared, so it will give you 5x. So AC is 5x. So with that, you know AC is 5x. And then you can calculate the length of the other side. So this is 5x, because AC is 5x. And then remember the wire is 32, the length is 32. So which means if you take 32 minus 5x minus 3x, 4x, it will give you minus 3x minus 4x, it should give you the length of EA or AE and the length of CD. So these two add up will be 32 minus 5x minus 3x minus 4x. So just divide by 2. You'll find the length of one side, AE or CD. So that's why you can say 2 times the CD, because CD and EA is the same length. And it gives you 32 minus 12x. That's why I mentioned it's 32 minus 3x minus 4x minus 5x. So it's 32 minus 12x. And then divide by 2, it will give you 16 minus 6x. So this is the length of CD. 16 minus 6x must be positive, because length of one side must be positive. So you can say 6x is less than 16. X less than 16 over 6, which is 8 over 3. So when you look for stationary value, x must be less than 8 over 3. So suppose to show area is 80 minus 24x squared, and then you look for stationary value, then show stationary value in part 3 is maximum. So you work out area of rectangle, then area of triangle, two things. Area of triangle will be half base times height, So it's half 3x times 4x, and it gives you 6x squared. Let's go back to the figure. So this is 5x. This is 5x, right? And this side, just now we worked out, right? Just now we worked out. Just now we worked out is 16 minus 6x. 16 minus 6x. So which means area should be 5x times 16 minus 6x. For rectangle is 5x times 16 minus 6x. And for the triangle, for rectangle is 5x times 16 minus 6x. And for the triangle will be half times 3x times 4x. It will be half times 3x times 4x. So that's why it's 5x times 16 minus 6x and half times 3x times 4x. So you get 6x squared for area triangle. And for rectangle is 5x times 16 minus 6x, which actually you add them up and simplify, it should give you 80x minus 24x squared, which is what you wanted to show. 80x minus 24x squared. After that, in part 3, you just do differentiation. So area is 80x minus 24x squared, right? So we find dA dx. Differentiate 80x, give you 80. This one will give you 2x. Differentiate x squared, give you 2x. So it gives you 48x, right? And then you set dA dx to 0. And you solve for x. It will be 5/3, yeah? And then you look for the area. So you sub x as 5/3, yeah? So you sub x as 5/3. So x sub as 5/3, and 5/3 squared, it gives you this. So the stationary value of A occurs when x is 5/3, and A, the value is 200/3, yeah? And then you work out the second derivative. You just put differentiate. If you differentiate, d2a dx squared, right, will be minus 48. Differentiate 80 gives you 0. Differentiate minus 48x gives you minus 48. No? So we just get minus 48, which means the second derivative will be negative, minus 48, when x is 5/3. So you imply maximum A by the second derivative test. So therefore, when x is 5/3, area is maximum, and the value is 200/3. So with that, we show that the stationary value in part 3 is maximum.